All right, everybody. So welcome to Unit 8. In this unit, we're going to be looking at statistics and probability. So believe it or not, the majority of statistics is counting. We want to count the number of possibilities and then all of those possibilities that are desired. So you can probably think of the common thing is flipping a coin. You have heads or tails, and do you want one of those? So you have two possibilities and one that you want, and there's a lot of different things you could look at, like a sports game. You don't know. Someone could, just for example, I know not all of you are sporty out there, but in a football game, you could score a touchdown on your first play. You could not. You could get a safety, different things like that. As you can see, there's a lot of possibilities that could happen. And so with that, you want to look at what all you actually want to happen. So some of this can get a little overwhelming. So that's why we use sets. And sets are actually something we looked at previously with the number systems. So think back to like the number systems when we had, let me get my pen, thought I was ready to go. When we had our whole numbers, the integers, and then it went on and on, right? We had our complex, we could start from the outside. Complex was every single number. Then you had like imaginary. And then the real numbers. Then rational. Or irrational. Oop, I didn't finish rational there. Rational, irrational, rational, irrational, then we had the integers, then we had our whole numbers. Feel like I'm missing one in there, but with each of those, they were different sets, and so like we had special letters for all of these, so like whole was the W, integers, remember, was the Z, complex was the C, imaginary was the fancy I, real was our R, rational was Q, and then irrational was P. So they each had, oh, natural, that's the one I'm missing, the natural numbers. Which were N, so that each of those had a specific letter. But not all sets have their own name or have their own letter, and we can have many possibilities to write these for our probabilities. And so to do that, we put our braces around them, or squiggly brackets. So what I mean by that is if you think about what are the possible outcomes of a coin toss. So if we had our set of possibilities, we do our brace, our squiggly bracket, and you could have either a heads or a tails. And then we end it. So that would be the example of the set of outcomes for a coin toss. If we were to keep going, then what are the odd numbers between 0 and 20? We'd have our set, and then we'd go all the odd numbers. So we'd have 1, 3, 5, 7, 9, 11, and so on. 13, 15, 17, 19, and then we'd end it. Okay, and these sets we can name however we want. So we could call these P for who knows possibilities, or O for odd. Doesn't really matter. Okay, but we want to compare these sets to each other. And so there's some terminologies that we have to use. So if we look at the following sets, we got U, which contains all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 10. A contains all the odd numbers 1, 3, 5, 7, 9. And then B contains 1 through 5. So the set U is what we call the universal set, because we will be using that to compare, using that set to compare the others to. So it's basically kind of like that's our world, and our other sets are going to be inside our world. The first term is called a subset, or we denote that by having the side, kind of looks like a C, but mainly it's a sideways U. And a subset is where, I gotta get to my marker, is where all the members of one set are contained in another set. So let me scroll down here to the next page. We still have our sets U on numbers 1 through 10, and then A and B. So if we look at which sets A or B are a subset of U. So what we got to do is see if all the members of A, first off, are in U. And so we got A is 1, 3, 5, 7, 9. And hey, 1, 3, 5, 7, 9. So all of A is in B. So the way we would write that is A, we do our sideways U, is a subset of U. Because all members of A are in U. Okay, now we got to look at B, see if B is a subset, and B are all the numbers 1 through 5, 1, 2, 3, 4, 5, and all of those are in U, so we would also say that, again, got to get to my colors, B is a subset of U. And we would say by the same reason, because all the members of B are in U. Okay, so that's a subset. Subset is where all the members of one set are in another set. Now we want to look at, to compare two sets are the intersection, which is an upside down U, and union, which is just a normal looking U. So the intersection of two or more sets contains elements that are in both sets. Or think and. So we want to look at what elements of this set are in both of them. So remember our sets A, alrighty, right here, A was equal to the odd numbers, so we had 1, 3, 5, 7, and 9. And B was 1 through 5. Okay, so the intersection, what is the intersection of sets A and B? So what sets are in A and B? So we would denote that as A intersect B, or A upside down U, B. So we'd have A intersect B is equal to, and we write this as a set, so we'd have the set, and we got to see what numbers are in both A and B. So we got 1, 3's in both of them, and 5's in both of them. 7 is in A, but it's not in B, same with 9. 2 is in B, but not in A, the same with 4. So we would write our set A intersect B would be the numbers 1, 3, and 5. Or oftentimes you'll see this as like as a shading. So let me just draw this real quick. So if we have our, just say we have two sets, the intersection would be whatever's in between there, what's in both of them. Okay, and then the next thing we want to look at is a union. And a union of two or more sets contain elements that are in either set. Or think or. So they can be in either A or B. So what's the union of A and B, or A union B? So we would write that again as A U B, or A union B, and that's equal to the set of all numbers that are in both of those sets. So we can write all the numbers that are in A as well as all the numbers in B. So we want to write these in numerical order if we can. So we got 1, let me use a different color so you can see that a little better. So we got 1, 2, 3, 4, 5. Those are in both of them. So we got the set numbers 1, 2, 3, 4, 5. And we don't write duplicates. So we got A, or 1 is already in there, 3 is already in there, 5's already in there. And now we got to put 7 and 9. So this would be 1, 2, 3, 4, 5, 7, 9. And that would be the set of A union B. And so if we were to do our shading of A union B, it would be everything that's in A as well as everything that's in B. So we would shade both of those there. All right. So now the last thing we want to look at is something called a complement, or you'll see it written as A with the apostrophe, or A prime is how we would say that, or A to the C, which means a complement. Okay, so the complement of a set compares a certain set, or whatever set, to the universal set. So it compares it to the universal set. It contains all the elements of the universal set, not contained in the designated set. So example with that is, what is the complement of A, or A prime, or A complement? So we're wanting to find everything in the universal set, which, a reminder, the universal set for this one was all the numbers through 10. Just to make sure. Yep, all the numbers through 10. That's a weird looking 3. Oh well. Did it include 10? Yes, it did. So we wanted to compare it to the universal set, and remember, A was all the odd numbers. So we got 1, 3, 5, 7, 9. So the complement would be anything that's in the universal set but not in A. So we'd have A prime, that's equal to this set of numbers. So we want everything that's not in A. So 1's in there, so we wouldn't use that. 3's in there. 5's in there. 7's in there, as well as 9. So all the numbers we didn't highlight would be in there. So we'd have 2, 4, 6, 8, and 10. So A prime, or A complement, would be 2, 4, 6, 8, and 10. Just for my OCD, make that the same. And so if we were to shade this guy, let's call, let me get this going here. So if we were to say this big rectangle is U and the little one is A, we're wanting everything in U that's not in A, so our shading would be everything around A. I know I'm kind of hitting it, but it's everything around A. Okay? All right. So here's a little bit of a review. A subset, remember we write with the horizontal or the sideways U. And the way that would look like, let me make this a little easier. So as if we had our rectangle, and let me make do that one, and then if I make another one, so this set here, the little one, I know I shaded over that, so let me do it this one. That would be a subset of this bigger set, let's call that A. So that would be a subset of that one there. And so remember, a subset is all elements of one set are found in another. Okay, and then also we go on with intersection. So intersection was where we had it like that. Union, we had our U. And then complement was where we had like A prime, or you also saw a complement. Okay, so I'll leave the example blank because we did examples up there. But intersection, again, we can think and. So it'd be elements in two or more sets. So if I make a picture here real quick, let me actually just copy this down once I get to the next one. So let's call that set A. Add another set there. Oop. So the complement would be everything in the middle there. Oop, I need to copy that. Give me a second. There's that one. All right. So the intersection, again, was everything in between. Union, if we just keep on shading, we'll go down, was, remember, it's think or. So it's all elements of two or more sets. So if we shade it, it would be everything. Pardon my really quick shade job. Guess it's not so quick. Okay, and then complement is any element in the universal set, not in the designated set. So if we said this was A and we wanted to find A complement, it'd be everything not in A. So it's shading everything out here. Again, maybe not so quick shade job. But also, since these elements of this other set are not in A, we would shade everything around that as well. Okay, so that's a quick overview of sets. Next time, in the other video in this lesson, we are going to look at probability. So make sure to check out the other video for that.